I've been quiet for a while on the Quanta hybrid machine here because, like I've told many, I just wanted to improve this thing to get it into kind of a real-world application. So I've made some improvements. So I'm going to show you what those improvements are and show you what happened after making those improvements. First of all, let's go around the machine. Some people have said, you know, we'd like to see the back. Well, this is the back. It's just got a bunch of screws. It's solid. It's kind of like a deep dish pizza box, kind of in a way, so it's slender. So anyway, what I did is I took this ATV battery here that was in service, and I ride pretty hard on an ATV, so it kind of beat up the battery, and it went from 12.5 volts and just immediately dropped down to about 9.5 volts. So I thought, okay, well, I'll just use it as a core replacement, get a new battery, which I did, but I decided to keep this one instead. And I thought, well, maybe I can, you know, help it out by trying to condition it with radiant. So I have that ability. So I ran radiant over and over and over and over, charge, discharge, and finally got it up to holding about a 10 volt charge, or just under 10 volts. But it'll hold it for a long period of time, which is kind of cool. So I decided to use this battery to run the Stargate motor here, and then charge these four smaller ATV batteries, which, because of the radiant conditioning on those will charge up to 13.5 volts. They've been well conditioned, and it's amazing because it takes this battery, if these run down, if I pull the power down to about, let's just say 11 volts on these, when this is running the Stargate motor, it drops down to about 9.6, 9.8 volts in the run condition, and it takes it about 15 minutes to take these from 11 volts up to about 13.5 volts. So I thought, wow, that's kind of cool. So there must be something here. So what if we ramp it up a bit and we buy some really giant deep cycle marine batteries, 105 amp hour batteries with 182 reserve capacity minutes, you know, these big old monster batteries here. And so I've got these batteries in series, as you can see here, and then over to this one. And so what I do is I use this battery as the run battery. So I connect the Stargate motor to this particular battery. There's the positive. I haven't connected the negative yet. And then it goes from DC to kinetic energy running the motor, then into AC, and then back to DC with a high potential difference back into the system. Only it's coming in from here to here, so it's charging all four of them. And it's very, very interesting because when you first start it up, here's what's on the meters right now. The one battery that's going to run is at 12.69 volts, and the other three are at 37.42 volts. But yet they're all connected in series. So we pull off this battery, but then we charge them all back up in series. And what that does is it takes a few minutes. Kind of interesting, because I've been charging and discharging these with this system now for only about a week, and it takes, with a big deep cycle battery, it may take me months to get these things conditioned correctly. But it's pretty fascinating what it does, because once the thing gets cranked up, it levels out, and by splitting the phases here, I can mix these phases on the three-phase alternator. And with the setting that I've currently got here, where this one's down and this one's up, and down here this one's up and this one's down, it'll just turn it into a system that will just balance the voltage out. It doesn't rise, it doesn't fall. Once it levels out, it stays the same, and it runs this motor, so it runs the system, and it does freaking nothing. It just runs the system, and maybe it'll run it for a day, maybe it'll run it for a week, maybe it'll run it for 50 years. Who knows? It'll run until this motor burns itself out, I'm sure. But it's interesting because I've let it go for hours, and it just doesn't do anything here. It just stays the same. And so, yeah, some people say, well, yeah, it could do work, though. You hook up a fan to it. Well, what good is a freaking fan going to do if you live in the Arctic? So, you know, I want some real world application that, okay, 3 or 4, actually I was going to buy a 5th deep cycle battery in here. I wanted to charge 4 big deep cycle batteries and use one to run, but the store only had 4, so I bought all 4. And yeah, they're expensive, but hey, you know, if you put the investment in up front and the system works, I mean, that's the only reason I would put the investment in, is if the system would work. And I thought this kind of proved that it might work, but so I took a gamble and went ahead and bought these to see if I could, you know, make that happen. But I mean, think about it. So I ran my big inverter over here. It's a 2,000 watt inverter, and it can surge 4,000 watts. So I used these 3 batteries, and I ran a drill press and I ran a bandsaw and a drill for, I don't know, over an hour, try to pull the batteries down so that I could see if this thing, you know, would charge them back up in kind of a real world situation again, and then see how much loss I had, and you know, go up between the difference of what it took to run the system and what I got back. And it's kind of a 3-to-1 ratio, so it's pretty interesting, you know, 3 back for the 1 that you put in. And okay, and maybe I shouldn't even have said that, but anyway, it's an interesting ratio. But hang on a second. I've got some notes. I wanted to cover some points. So here's what I've done. Here's what I've done that's different. On the rotor here, I've added an additional rotor magnet. So you've got this one, and it comes around. You've got this one here, and back to this one. So 2 rotor magnets. So I've got the 2 different positions, and so to kind of cover the points here, you know, with the increased efficiency here, this motor will run at 1800 RPM. It actually, without the Stargate configuration, and I've just got it moderately with the full stack of the small magnets and none of the big bars in here, because if I put them in here, the RPM would be greater than this hack job of a build could handle, and the thing would probably just fly apart, and I don't want to risk that. I've spent too much time in getting it to the point that it's at right now today. So I like to keep it around 1800 RPM. This thing, without the Stargate, will run about 1550 to 1600 RPM. Let's just call it 1600 RPM. And then with the Stargate on here, it adds that extra 200 RPM, so I gain that bit of efficiency here. It doesn't draw any more power. You just get that extra RPM, and the torque seems to stay the same. Everything runs at the same, you know, as that 200 extra speed, and even under load, it works really, really well. So there's one thing. Then the double magnets on the rotor. Then what I did here on the electromagnet is I pulled it all the way back to the case, the half-inch thick case here, where it typically would sit real close to the rotor here. Now I've got an extra 1 inch of space here, so that when the rotor magnet comes around, it's probably, you know, 1.5 inches away from this. So this doesn't do anything, and I don't pulse it, but it does kind of help bridge the gap between the end of the stator track and the beginning of the next one, because of this being circular. You can see where the side of this one kind of touches the outer edge, as does this one here touch the outer edge of this inside the case where you can't see. And so it kind of, you know, like I said, kind of helps bridge that gap without giving it its own polarity that's real strong of a neo, because if you close this whole thing, you end up with a closed circuit of magnetic, and it sort of cancels it out. And then you might as well pull all the magnets out and just have a freewheel spinning, you know, without any rotor stator relationship. I don't want that. I added the second magnet so that I can increase the torque, and it does. And then here's the analogy. This point here is like a speed bump. You get in a car and you drive over a speed bump at, let's say, 1 mile an hour, and when you hit that speed bump, that car is just going to stop. So you give it a little gas, and the front wheels go over it, and then you give it a little gas, and the back wheels go over it, and that's it. Okay, hit that same speed bump at 60 miles an hour. What do you got? but and you're over it. Well, that's the same thing this does when the rotor magnet comes past this. After about 200 RPM, it's and it's nothing. So I added the second one, and yes, it proved the point. Yes, that does work. Well, I'm not running it at 200 RPM. I'm running it at 1800 RPM. So that isn't even a, it's nothing but a buzz, and it's gone. So it's interesting. But the most important thing that I feel is the difference here inside on the axial flux. I've eliminated, I used to have a stack of 3 magnets at the top here and 2 magnets at the bottom here, and which put the, and they're all N52s, which put them close to the coil set and gave me, a nice high current, but that's not what was needed. So I took all those off, but I did something unusual. I put, as you can see here, let's see if I can show this without being too dark in here. I've got 2 here, and then I've got 1, and then I've got 2 up here. So what that does is on the phases, this is a 3-phase alternator, and there's 12 coils. So each rotation you're engaging the phases 12 times, but you're engaging with a higher strength of magnetic flux and then a low strength. Look at the distance. I mean, this is about 5/8 of a distance from this rotor magnet here to the coils, and 5/8 or 3/4 of a distance, inch of distance on the ones that are mounted to the big rotor here, back in here. And so, you're you're not, when you try to read the amperage on the output of this thing, it reads pretty much 0. But the potential difference is extremely high, because by simply switching the phases, I can get an 80 volt output. Then the next switch that I do, combination of switches that I do, I can get 90 or 92 volt output. Then I can do another combination that jumps up to 140. And then I can do another combination that jumps up to 160 volts. And that's pretty much where it maxes out. Well, I don't want to, really put a steady 160 volts into this, because that resistance will, just be fighting it. But I do want to have something that allows this motor to run as if it was just idling, or as if it was totally free and not under load. And that's what I've done. But I've added this extra little cool thing here. The cool thing that's added is the difference between here to here to here. From one phase engages with extra strength, then the next phase engages real weak, then the next with extra strength. So what you end up getting is a harmonic oscillation of output power of tremendous potential difference in a real small wave, kind of a sinusoidal wave, only real fast, high frequency, because it's running it at 1800 RPM with 12 cycles per second. Well, 1800 RPM mathematically comes down to 30 revolutions per second. Okay, 30 revolutions per second and 12 engagements of the phases on the axial flux alternator gives you, I think it's 350 or 360 cycles per second. And that's pretty high. So those little sinusoidal waves are, really, really tiny, and it's just this pulsing, oscillating power of high, low, high, low, high, low, high, low, high, low. And it's fascinating. So, and then to top it all off, going from DC to power this load here in kinetic energy and running the rotor and, turning out into AC, converting back to DC at a high potential difference is that's the key. And the thing about it is, with using hardly anything of this, the efficiency, when you start this up without anything engaged, this will run at about 1850 RPM, something like 1850, 1840. And then when you put it under power, if you just want to run itself, it drops down about 40 RPM. From 1840 to 40 RPM drop is nothing. So this thing, will run, if you're just going to run the system without trying to charge these extra batteries. They're just going to run the system like it sits here, and so that the power just stays the same and just runs for hours and hours. This motor just barely gets warm. I mean, all that time, because it's really not working very hard. It is consuming energy, of course, from the battery in order to run, but it's not getting hot. It's just got a nice little warm feel to it, just warmer than room temperature, and yet this thing is spinning at 1800 RPM and keeping on a 5-pound flywheel and keeping the whole system running with all the friction of the direct connection here, and the bearings in the rotor and the front and the back, and just everything. I mean, all that friction, even the air friction. This thing puts out a lot of wind just when these magnets pass through these openings here, just because the magnet's raised up. Maybe I should put an airfoil on the magnet or something. But anyway, but the thing will really turn even connected in the direct connection. I mean, look at this. You see, it's got torque, and then it can even rock back and forth between the poles. It's really amazing that you've got that kind of torque on this thing. So, but if you think about it, here's the other thing that I thought, okay, this has got to be making a difference here. I've got this rotor magnet here and the one over here spinning 1800 RPM inside this continuous stator field, 1800 RPM. Don't you know that look at the proximity of these giant N52s. These things will lift like 400 pounds or so. They're monster N52s. There's two of them. And look how close the proximity is here to the coil sets. Very, very close. Now, think about that rotating magnetic field. 1800 RPM with these two N52s and the relationship of the stator field. On top of that, you've got this ball of magnetic flux flowing in there, rotating super fast around this coil set the whole time, while you've also got N52s on these rotors engaging the coils to get that high frequency pulsating sinusoidal wave of potential difference to go back into these batteries. Now that's pretty darn amazing. I'm sorry if I'm being long-winded with this, but it's kind of a long explanation, and I wanted to cover those points, about the frequency being high and this high-low sinusoidal kind of output, so giving you that harmonic oscillation of potential difference going back into these batteries. All these things are key to making a system like this really work and putting it into a real-world application where you can take deep cycle batteries and charge them. Charging deep cycle batteries with a tiny little 6-inch axial flux alternator? There's got to be something more behind it than that. How in the world could you do that? These things usually take a lot of amps to charge. Well, I'm going to condition them. It's going to take me some time, and they're just going to charge faster and faster, and the whole system will improve in efficiency and be able to use the output of these for whatever purpose you might have. Whether it be this purpose here or some other purpose, who knows. But anyway, that's the goal there. So I'm going to go ahead and hook this up. I'm going to have to set the camera down for a minute, and because it's going to take two hands, and I'm holding the camera with one hand, and I've got this stupid pencil with the other. So there we go. And let's see, anything else I wanted to cover before I turn this on? I think that's pretty much it. I'll kind of sum it up after we run it a little bit if you care to hear this. But so let me set this down momentarily. Okay, I've just started it up, and you can see the fluctuation here. 1253 pulls that down on the run battery here, and 3744 on the three that are charging, because I've got the 2 meters connected to the three from here to here, and the other meter is just connected to the one here and here. So you can see it'll take a few minutes for it to kind of settle down and level out. So now we're at 12.51, and this is bumped up 37.45, about to go to 46. And this is in the setting that once it levels out, it will just stay at that run speed for in an indeterminate amount of time. I don't know how long. I've done it for a few hours, and it just keeps on going. But let's see what the RPM is here. Let's get it on there. There we go. 1800 to, okay, so roughly 1800 RPM, and that's under load. So that's what I was telling you before, that if it starts out at 1840 and you put it under load, it drops down to the 1800 and just runs and runs and runs, and the motor just stays just a little above room temperature. So here we got, now it's down to 12.5 on the run and 37.46 on the charging batteries. So no great difference there. It'll finally level itself out, and maybe it'll stay at this level here, 12.5 and 37.46. Maybe it'll drop down to 12.49, and this might go up to 37.47, whatever. But it'll level itself out. Yeah, there it went up to 37.47. It levels itself out, and it just hangs there while it just runs the system. And like I said earlier, does nothing, just runs the system, which is cool. But what's that give you? It's just running the system. So that's that. Now I'm going to step it up and cross one of the phases here. Now you can hear the difference in tone, and it slows it down a little bit. Let's see what it pulls it down to. Oops, get this thing on here. Pulls it down to 17. Oh, sorry, I'm one-handed. 1712. Let's call it that. It was 1713. It goes up and down. So 1712. So we've dropped. So we're down maybe 100 RPM, or a little over 100 RPM, to put this thing under a load condition that will still, even after hours of running, this will be a little bit warmer than that, but it never gets hot. It just stays a little bit warmer because it's still hardly doing much effort. Now remember, without the Stargate and without being under load, this thing will turn at 1600 RPM. Now we've added the Stargate, we've got it under load in a much higher condition to where it's going to charge these batteries, and it's still running over 1700 RPM. That's pretty amazing. Now let's see what the power is doing. Okay, so you can see it pulled this down, 12.46. Well, look at this, jumped way the heck up, and it's jumping up faster, 37.55. Staying at 12.46. Now it gets at a point where the power coming out of the run battery kind of levels itself off again, and yet this just keeps increasing and increasing and increasing, because what we're doing is we're feeding that power back into the run battery, connected in series with these other three batteries. So it is in essence giving a charge back to this battery being connected in series with the rest of them, while it's sucking the power out to run the motor. And yet at the same time, the voltage rises in these three batteries. So especially with deep cycle, that's pretty amazing. So 12.45, 37.56. See? Now it takes some time to charge these big deep cycle batteries. Maybe if you drain them way down, it might take you, I don't know, 5-6 hours maybe to charge these back up to full capacity with the one battery. Then you're going to have to take this one and switch it for one of these, let one of these charged up ones be the run battery, and then let it charge back up with the other three at the same time, and rotate them like that. That's why I wanted to have 4, because I thought switching 2 of them back and forth and having 3 of them to do something interesting would be a much better situation. Still at 12.45, 37.57. You see? Now this may drop down to 12.44, but not after this has come way the heck up. Well, this video is already too long, but we could hang in there for a much longer period of time and watch this, because it's doing nothing but just making some changes here. Now we're still at 1245, 37.58. So these three batteries continue to rise, while this one stays the same, because the power is coming in and flowing through it at a high potential difference than what's going out of this thing. From here, DC, AC, back to DC, with a big potential difference. So right now we're putting in probably, let's see, at this setting I think I've got about, it's either 80 or 90 volts that's going, well, that's the second setting, so it must be about 90 volts coming back into this system. That's kind of high voltage too for what should have, you know, a little over 50 volts, but and no amperage, but yet what do we got now? 1245, 3759. You see, it's staying the same. It keeps on rising, and then it'll just keep on rising and rising and rising and rising until these things will come up to, eventually, when you divide the total number here by 3 for these three batteries, I think it wants to try to, at this point, since these aren't conditioned yet, I think it gets up to about 12.6, 12.7 volts each, something like that, which still isn't bad. And then this one will drop to get these up to that point. This, well, depending on how discharged they are, but this one will drop down. If it starts out at 12.6, it may end up at 12.2 when you're looking at it on here, or 12.3. But then when you disconnect the system, this thing's been charged over and over and over. So it may have a little bit more conditioning than these, because I've played around with this one a little bit too. But it'll bounce back to maybe 12.4, 12.45, kind of what it is here, while it's not running. You know, after you just see it drop down. It's trying to drop down to 12.44, but look, 3760 already, and we're finally dropping 1/100th of a volt here. Trying to drop. See? It's crazy, and this is boring you to tears. But anyway, that's it. I wanted to show you this. I wanted everybody to know that, you know, I'm not just sitting around doing nothing. I keep making improvements. This is just one machine. Wait till you see my big charger. This Quanta Hybrid is cool, but I've got another one that's going to thrill you as well. All of these are fun to work with, and all these will do something. So see you next time. Just dropped at 42. This is 10 minutes later. It's trying to drop to 42. Look at that, 37.7.